Mercury is quite a peculiar planet, and in fact it's peculiar in several different aspects. To begin with, it is the smallest planet in the solar system. And yes, some might think it's Pluto, but no. Remember that Pluto no longer counts as a planet. We'll talk about that another time, the whole story of Pluto and so on. But now we're with Mercury, so let's focus. It is the smallest planet and also the one that is closest to the Sun. It is at slightly less than half the distance from Earth at 0.4 astronomical units. And this really is very close to the Sun, and it is important for several reasons. For example, it can only be seen either at dawn or at dusk, when the Sun is just below the horizon and we can see it. This happens with the planets that are inside Earth's orbit, which are really two, Mercury and Venus. Also, it turns out that because it is so close, it is the one that moves the fastest. You know that the orbits in general are a balance between the gravity of the Sun, which pulls inward, and the speed of the planet around it, which is what prevents it from falling, right? The planet is always like escaping from that gravity that tends to pull it towards, in this case, towards the Sun. Now, in this balance, the closer you are to the Sun, the stronger the gravity pulls and the faster you have to move to not fall. In classical mythology, Mercury was the messenger of the gods, Mercury for the Romans, Hermes for the Greeks, and in classical art, he is often depicted with wings on his feet, suggesting, implying that he is very fast, and that's why he would be the messenger, I say, because, well, it seems that in Rome, the messaging services must have worked very well. If it were Amazon here, they probably wouldn't have put wings on him. Who knows what they would have put. The name Mercury is associated with the day of the week, Wednesday. And I also had a fact that I discovered, that I realized after reflecting a lot on the subject, and it is that it is the only planet that shares its name with a chemical element, although with the caveat that one is written in uppercase and the other in lowercase. Of course, there is no relation. The planet Mercury has nothing to do with the element mercury. We might even ask ourselves just to keep dragging out this nonsense more than necessary if there is ever Mercury on Mercury, and the answer would be yes, but more or less the same as on any other planet. I mean, it would be like asking if there is Earth on Earth. But anyway, returning to the topic, Mercury is also unique in that it has had an important, or that it has been historically important in the development of physics, because its movement was the first empirical proof of general relativity. In 1915, Albert Einstein, as it is often said, publishes his general theory of relativity, which is possibly the pinnacle of his thought, and still 100 years later remains one of the pillars of modern physics. It is one of the most successful theories in history, and we are still conducting tests with new experiments that, well, continue to confirm it. The thing is, the effects of relativity are very, very subtle. It is very difficult to make measurements of anything that can distinguish gravity from Newton, from the geometric formulation that Einstein had developed. And at that time, a century ago, you can imagine it was even more difficult to set up experiments because there wasn't the technological capability we have today. At that moment, there was a test that astronomy could provide, and it's called, pay attention to the name, I'll repeat it later, the precession of the perihelion of Mercury. The precession of Mercury's perihelion. And what does this mean? Well, it's simple. I will try to explain it with a quick explanation. It turns out that the orbits of the planets are not perfect circles. The planets do not move in circles, but they are slightly elongated. They are, mathematically, we would say they are ellipses. But let's say we can think of them as a slightly flattened circle, but very little, right? They are almost circular. But to understand the problem, let's imagine they were really elongated like a cigar, very elliptical. Entonces, would have a situation where the orbit has two extremes, okay? There are two extreme points through which the planet passes in its orbit. Well, it turns out that the sun is closer to one of those extreme points. If the orbit were completely circular, the sun would be in the center and always at the same distance. But as we flatten it more and more from the circle towards that cigar shape, the sun is increasingly closer to one of the ends. Well, that point closest to the sun is called the perihelion. Well, the curious thing is that the orbit is not always the same, but that cigar shape in which the planet moves rotates on itself. It rotates. The orbit itself rotates, and this movement of the orbit is called precession. So saying the precession of the perihelion is a way of saying that the point closest to the sun is in turn rotating around the sun very slowly. They could have called it the rotation of the orbit, but of course, it sounds better the other way. Well, the effect, as I say, is very small. In the case of Mercury's perihelion, this rotation is on the order of 1 degree every 1,000 years or something like that. But it is measurable and was already known since the 19th century, when it was discovered that Mercury experienced this change, this precession of the perihelion. It posed a serious problem because Newton's theory says that if you have two objects, like in this case the Sun and Mercury, the orbits have to be closed curves. That is to say, this precession should not exist. But of course, the solar system does not consist only of the Sun and Mercury. There are the other planets that also influence each other and become perturbed. And in this case, they perturb Mercury's orbit. When the calculations were done, it was seen that the perturbations from other planets on Mercury's orbit could explain part of the precession, but only partially, not completely. There was something left, an excess of precession that could not be explained with the normal Newtonian gravity we have always known. For a long time, the possible origin of that excess precession was debated, but in the end, the answer would come with Einstein and general relativity, because his theory does not work exactly like Newton's, although it is very similar, the effects it produces, and it is very difficult to find the differences. But right here, we encounter one of those small differences. As I mentioned the day before, Newton's gravity between two bodies always produces closed orbits. No? The same path is always followed in each orbit. But in relativity, it is not like that. The orbits are not closed. Instead, there is a little bit of precession as the orbit rotates a little. And this effect is more important the closer we are to the Sun. That's why it was first observed in Mercury. It was where this effect was first measured. It's not that the other planets don't have it, they do have it. There is also precession, but it is much smaller than Mercury's and had not been detected until later. When Einstein did his calculations with his new theory in 1915, he found that Mercury should have a precession of about 40 arcseconds per century, which is exactly the amount of observed precession that had not been explained. So Mercury provided what ended up being the first proof of the theory of general relativity, which, well, as I say, remains one of the pillars of current physics. As an interesting anecdote, we can mention that in the time that passed from when the precession was discovered until it could be explained, which was about 50 years, other possible ideas, other explanations were proposed. And the most striking one, without a doubt, was the hypothesis of Vulcan, which had a lot of impact in its time. The French astronomer Urbain Le Verrier was the main protagonist of the story. To begin with, he was the first to realize that there was something strange about Mercury's movement. He had done the calculations and discovered that the planet's position did not match. The explanation that seemed most logical to him was that there must be another planet still undiscovered that was even more interior than Mercury. A planet so close to the Sun should be very hot, and that's why it was named Vulcan, the god of fire. This idea resonated quite a bit in the scientific community, which considered it highly plausible, especially considering that Le Verrier had just predicted the existence of Neptune, which had been discovered shortly before, precisely in this way. But in the end, it turned out that Vulcan did not exist. Today we know that there are no planets closer to the Sun than Mercury. It is speculated, however, that there could be asteroids, a population of asteroids that for now has not been found, and this population of hypothetical objects is called volcanoids, precisely in reference to that idea of the planet. If volcanoes exist, it is very plausible that they have not been detected until now because they are very small and so close to the sun. It is difficult to observe something near the sun. As for Mercury itself, it is a very inhospitable world. It has no atmosphere. It has a thin exosphere, which is a kind of very, very tenuous gas that surrounds it and is made of atoms that are continuously stripped from the surface by the solar wind or also by impacts from small micrometeorites. That exosphere is not permanent. It is lost to space, but at the same time, it is generated by the evaporation of new atoms from the surface. So there is a balance, a dynamic balance between what is lost and what is formed being stripped from the surface. Without an atmosphere, the temperature has a brutal contrast between day and night. In fact, it is the greatest day-night contrast in the entire solar system, because during the day the temperature exceeds 400 degrees Celsius, that is, it is similar to that of Venus, but at night it can reach 170 below zero. There is almost 600 degrees of difference between day and night. And speaking of day and night, the rotation of Mercury is also quite peculiar. A year, which is the time it takes to orbit the sun, lasts 88 days. 88 Earth days, I mean. But here's the curious part. A day on Mercury, the time it takes to rotate on its axis is 2 of its years. That is to say, Mercury rotates on its axis, and in that time it has completed 2 full orbits around the sun. It is in an orbital and rotational resonance. Another peculiarity it has is its core, the heart of the planet, which is thought to be very large. Mercury has a very large heart, yes. It is a planet that is very massive for its size, and according to planetary geology models, the only way to fit these parameters, its mass and its size, is that it has a very large core that should occupy practically half of the planet's volume. In addition to being so large a cometa cubierta, the core must have a very high iron composition, which is also unusual. There are different hypotheses to explain these anomalies, but as of today we do not know which one is correct, and we probably will not know until the Bepi-Colombo mission arrives, which is scheduled for the year 2025 and is supposed to investigate this issue in detail. It is a planet about which we still know quite little. I would say we know much less about it than the other planets of the inner solar system. And this is for several reasons. On one hand, being so close to the sun, it is difficult to observe with traditional telescopes. It is in the middle of the brightness in the atmosphere near the sun. And furthermore, it is very difficult to send space probes there. Let's remember what we discussed in the previous video about the sun, that it is more difficult to send spacecraft inward into the inner solar system than to send them outward. Being such an inhospitable world, and with how costly it is to go there, it surely hasn't been a top priority for space agencies, but it certainly has many questions. Mercury has been visited by 2 probes that have provided us with almost all the information we have. First, Mariner 10 passed by there in the 1970s and did not enter orbit, but made 3 close flybys and was able to make observations and take images during those passes. And especially much more recently, the Messenger mission, which entered orbit and was analyzing Mercury very thoroughly between 2011 and 2015. Mercury's surface is somewhat similar to the Moon's, full of impact craters. It is an old surface because it is a world where there is practically no erosion. It has no atmosphere, no liquid water, nor any other process that could erase these impacts. In general, craters on planets are like a geological clock that tells us how much a surface has evolved. The history reconstructed from the craters tells us about a fairly common chronology in the solar system. A first bombardment of the planet occurred shortly after it formed, about 4,600,000,000 years ago. And then there was another later episode, the late heavy bombardment, about 3,800,000,000 years ago. It is thought that these 2 bombardments took place throughout the solar system and also on Earth and the Moon. Evidence of water ice has been found near Mercury's poles, and this was already suspected before radar observations made in the 1990s and has been confirmed by the Messenger probe. Surely the ice is found in areas of perpetual shadow and is buried under the surface dust, and for this reason it does not evaporate, but the origin of this water is not clear. So it could be, perhaps it's a possibility, that it was deposited there by comet impacts. What is clear is that Mercury seems to have had some level of volcanic activity until relatively recent periods. The MESSENGER probe has found volcanic complexes that may have been active until about 1 billion years ago, although this is still quite uncertain. But perhaps the most interesting thing about Mercury is the magnetosphere. Mercury has a magnetic field that is much weaker than Earth's, but being so close to the Sun, it couples with solar magnetism and leads to very interesting interactions. Sometimes a kind of magnetic tornadoes form that create a sort of funnel and channel the solar wind plasma directly to the planet's surface. From a certain point of view, it could be considered a kind of natural particle collider. The Bepi Colombo mission was launched in 2018 and will arrive at Mercury in 2025, after making several flybys of Earth and Venus to perform these gravity assist maneuvers to slow down and enter the inner solar system. It carries one orbiter to study the magnetosphere and another for the surface of Mercury. And it is to be expected that if all goes well, the next qualitative leap in the study of this small planet with an iron heart will occur there. We continue. If you join me, we are going to Venus. See you there in the next video.